Okay, so here what we have is that we got AB and it's bisected at E, so this is the midpoint, this point E. And AB is extended from A to F, this point F up here. Then we're gonna have this relation guaranteed, that the rectangle with side lengths AF and BF plus the square on AE, the square on AE, and that's also equal to the square on BE, but for our purposes it's easier if we write it AE, is equal to the square on EF. So we want to first, to prove this, we're going to construct the square on EF. Now, I'm not going to do the actual construction here, but I want to just draw this out as best I can. So I'm going to construct the square on EF, something like this. And then now I have the square on EF. I might need to label these points. So once I have the square on EF, then I'm going to draw, let's say AC perpendicular to BF, or whatever you want to call this, AB, or let's say BF. Okay, which we could also do. So I'm going to draw this line like this. And then I'm just going to say find C on, let's call this FD, on FD, such that FC is equal to FA. So then this is the point C, let's say. And then we draw CK perpendicular to FD all the way down. So I'm going to draw this line all the way down to here, like so. And now we just want to look, and we just want to sort of state, we're going to say all foregons that, and we could take our time to prove this statement, all foregons that appear rectangular are rectangular. Okay. And yeah, we could prove this statement that essentially, like, FC, and then I don't know, whatever we want to call this, A, B, C, D, E, F, let's say G, whatever, H. I made that K, so okay, so let's put this K. Here we go, K, H, whatever. And then now we're going to say, okay, so all foregons that appear rectangular actually are rectangular. Now we need to just sort of state some things. We just need to say AE equals BE, definition of midpoint. And then we could say, AF is the same thing as EK. And we have this, right? So I need to extend this all the way down. So I didn't finish, so I got to extend CK all the way down. I should have drawn it all the way down. And then drawn this. Why? Because I need to talk about this entire rectangle. So now let's do this in a few different colors. Let's look at what we have. So we know, right, I just said that AE is the same thing as BE. So I put a single tick here. And then we also know that everything's a rectangle, so then this is the same, right? The opposite sides in a rectangle are congruent. Double tick, right? So now the area of this rectangle we should see is the same thing, or the area of this rectangle, right? The area of this rectangle is the same thing as the area of this rectangle. And let's call it alpha, that area. Now let's move over to here and let's look at FD. So FD equals FE. And now let's break up what FD and FE are. So FD equals FC plus CD, and FE equals FA plus AE. And then now we know that FC is the same thing as FA from how I found C. So, and these things are equal to each other. So I have FC plus CD equals, what did I do? Equals, yikes, equals FA plus FE. But FA equals FC. So then this implies when I subtract FC on both sides, then I'm going to get CD equals FE. So then that means that this is the same thing as, wait, I messed up. FC is the same thing as FA. Yeah, so then, what did I mess up? AE. AE. I apologize. Okay, so let's just go back. Instead of writing, right, I should have wrote, when I substituted, I should have wrote that this over here, right, is FA, not FE. And then once I have that, right, this implies CD is equal to AE. And then that just means that this CD, just this piece, is not a double tick, it's a single tick, and this is a double tick. So it's just saying that AE is the same thing as CD. And that's important because FA was made the same thing as FC. And then this is going to be a square here because these are all rectangles. And then this also has the area alpha. Now, after you show, since we know that all of these are rectangles, CDGF is a rectangle, so then this must be a single tick. And now you just fill in all the remaining areas and you're going to get the result. So you can just say, right, that this is beta, right, let's say, and then this is gamma. So let's look at the left-hand side. AF times BF plus AE squared is equal to, right? Well, AF, right, is this part, which is the same thing as FC. And then BF is this whole thing. So this whole rectangle here is 2 alpha plus beta. And then AE squared, right? This AE squared is the single tick squared. That's AE, so this is AE. So then this is AE because this is going to be a square. And then gamma is AE squared. Similarly, if we look at AF squared, that's equal to, right? Is it AF? No, it's E. What do I want? I want the right-hand side. The right-hand side is EF squared. So if we look at EF squared, we're looking at that square, right? This square. This is EF squared. And again, what we'll get is the same thing. We'll see that it's going to be beta plus alpha plus gamma, which is 2 alpha plus beta plus gamma. And then these things together show the result that you have AF times BF plus AE squared is equal to EF squared. And now you're done. And this is perfectly fine. Everything here, these words are enough. You can just state sort of something like this. All foregrounds that appear rectangular are rectangular.